This is the second video in a 4-part series that explains how to effectively manage electrical demand to realize savings and reduce future cost risks in situations where rate structures are changing. In the first video, you learned the basic concepts of industrial demand management and the benefits of managing electrical demand. In this video, we'll review common demand management strategies and when to use them. Typical approaches to managing your electrical demand fall into 3 main categories: load shaving, load shifting, and load balancing. Load shaving refers to the process of reducing demand during peak periods by curtailing electricity use or switching to an on-site power source to remove electrical demand from the grid. A simple example of load shaving would be to manually or automatically shut down equipment during peak periods. Load shaving can also be achieved by using on-site generation to reduce grid demand during certain periods. Load shaving is often a good option if you have flexibility in your operations to reduce demand for a moderate or long period of time, such as 2 hours or more. Examples of where load shaving is commonly used include utility demand response programs, where participants reduce demand in response to a signal from the utility, or Ontario's Class A rate structure, where participants reduce demand when a coincident peak is predicted. Load shaving can be challenging. Implementing load shaving requires behavioral changes by personnel to shut down or avoid using equipment during peak periods. Additional control equipment may be needed. If on-site generation is used, fuel costs and greenhouse gas emissions may increase. You may need to check your certificate of authorization to make sure this use of a generator is allowed. Load shifting is another way to reduce energy demand during peak periods by shifting that demand to off-peak periods. This can be achieved by shifting production or operations to off-peak times, pre-cooling facilities to reduce cooling loads during peak times, or using batteries that charge off-peak and then discharge during peak periods. Load shifting can be useful if you're able to shift the timing of your operations, or if you have the flexibility to store energy, including thermal storage or materials in some way, such as pre-cooling your conditioned spaces or stockpiling materials. Load shifting can also be accomplished with batteries if your operations aren't flexible. Load shifting is often used when demand needs to be reduced for a short to moderate period of time, such as less than 4 hours. It can be used to take advantage of demand response programs, capacity auctions, or other rate structures that encourage occasional peak avoidance, like the IESO's Class A rate structure. The challenges of load shifting can include issues with rescheduling employee shifts or the need to upgrade equipment controls. Some operations may need to maintain narrow temperature bands or require continuous flow, limiting their ability to pre-cool or stockpile materials. There may also be additional costs to purchase and maintain on-site energy storage equipment. The final option for industrial demand management is load balancing. Load balancing is achieved by coordinating individual loads to reduce spikes in demand. Load balancing can be achieved through practices such as staggering the startup of motors or chillers, or controlling when electric vehicles can be charged. Load balancing is typically used to reduce monthly peak demand charges, although it is emerging as a strategy to mitigate electrical capacity restrictions when deploying vehicle charging infrastructure. Load balancing opportunities may be limited depending on the nature of your equipment and operations, and typically require specialized control equipment such as motor soft starters, VFDs, or load balancing software. In the next video, we'll look at how to identify opportunities to reduce demand in your facility.